All right, so we're going to talk about the different types of reactivity that we might be seeing when dealing with nuclear reactions. So we know nuclear reactions are things that happen inside the nucleus, okay? So these are things that happen with protons and neutrons, and then they actually emit this energy out into the atmosphere. What type of energy are we talking about that they emit? Well, they can emit things called alpha particles. This is one of them. Alpha particles, we're going to start showing them as this Greek symbol for alpha. What alpha particles are their helium nuclei. What that means is it has a mass number of 4, meaning it has 2 protons and 2 neutrons. You might see it looking like this, or you might see it looking like this at the alpha. I'm showing this, an alpha particle. It has a charge of +2 because remember it's a helium nuclei. Nuclei do not have electrons around them. So the charge of +2, denoting that it has 2 protons. Because it has 2 protons, it has a mass of 6.64 times 10 to the negative 24th kilograms. This might seem ridiculously small because it's 10 to the negative 24th, but actually this is a relatively large particle compared to like other particles that are emitted. So this is a pretty big particle, and actually, so when nuclear reactions emit alpha particles, they're not dangerous to us at all. They actually can be blocked by things as thin as paper. So our clothing can block them. They actually they don't have a high penetrating power. So we actually shouldn't be nervous when dealing with alpha particles or alpha decay. The second type of particle that it might be emitted is beta particles, and you'll see this Greek letter B indicating that it's a beta particle. And what beta particles are also called are they're electrons. They're high-speed electrons that might be emitted when dealing with nuclear reactions. So because they're electrons, they're going to be denoted having a mass number of 0 because comparatively the mass of electrons are nothing, and they have a charge of -1. Or you might see this B saying the same thing, but they're identical to each other, saying this is a beta particle. Same thing. The charge of a beta particle is a -1 charge, and the mass is pretty small, 9.11 times 10 to the negative 28 kilograms, very small compared to the alpha particle. And things that can block it still can be blocked. It's actually not that dangerous. But things have to be a little bit thicker. Foil is able to block it. So it's really not that terrible for us. We can, a lot of things are able to block the electrons, even though they seem ridiculously small as well. We can actually block those from us too. The most dangerous kind of radiation that's going to be emitted from radioactive materials or nuclear reactions are gamma rays. Gamma rays, the symbol for gamma is an upside down, looks like a sideways alpha. And this is high energy electromagnetic radiation. These are things like, if you could think of something along the lines of X-rays, that's an electromagnetic radiation also. It's actually more intense than X-rays. So when you go and get your X-ray from like the dentist and they make you put an apron on to have that lead actually blocks those X-rays. These actually have more penetrating power than X-rays. Those can actually be blocked, can penetrate through that lead. Some of it can. So it's really, really dangerous for us. A symbol might look like this. It has no mass. It has no charge. It has a charge of 0. It has no mass. And to block it, lead partially blocks it. Concrete definitely blocks it. That's why when you see like nuclear power plants, you'll see them. You'll see the big concrete buildings. That's to block out the gamma rays. Also in Chernobyl, to stop the actual radiation affecting the atmosphere, they poured tons and tons of concrete on the reactors to block that gamma radiation so it wouldn't escape. So concrete actually is a good blocker of gamma rays, but these are very, very dangerous. If they do get to our skin, they actually can mutate our DNA, and then in the effect, have our children and offspring will have mutations, and so that gamma rays are very dangerous in that way. So these are the 3 types of radioactivity that you'll see when dealing with nuclear reactions.